So we have discussed the integrated rate law for 0th order. Now it's your turn to find the integration for the first order and also for the second order. You have to do the same thing. So you have to write down the dA over dt is equal to KAN. So you have to exchange n now with either 1 or 2. So you have minus dA over dt is equal to Ka, like that. For the first order, n minus dA over dt equal to Ka power to the second for the second order. Again, you have to integrate this. Integrate. You have to move the dt first, yeah. Let me rewrite that. So in this case, it's minus 1 over a dA equal to k dt, okay, for the first order. For the second order, it's minus, let's write down this first, minus a power to the second dA equal to k dt. Yeah. So you have to integrate it here. Integrate. Integrate from a0 again to at, from 0 to t, a0 to at as well. This one, 0 to t. So then you will find a simple linear equation for the first order and also for the second order, just like what we found for the for the 0th order that we have discussed before. So now, if you have integrated everything correctly, you will end up with this table. You can write the order, is it 0th order, first order, or second order? And then you can write the rate law. For 0th order is R equal to K. For the first order is R equal to K multiplied by A. And for the second order, it's R equal to K multiplied by A squared. And if you have integrated it correctly, you will get this linear equations. As you can see here, for the 0th order, it is AT equal to A0 minus KT. For the first order, it is ln AT, or the natural logarithmic of AT, equal to ln A0 minus KT. And for the second order, it is 1 over AT equal to KT plus 1 over A0. Note that here, mostly the K is negative, so minus K minus K. The K itself is positive, but it will be minus K over here. However, for the second order, it is plus K. Again, the value of the K itself is always positive. Now, based on these linear equations, we can have linear regression, and then again, we can perform this in calculator to find which R squared that is the closest to 1, yeah, or 0.99. For the 0th order, what we will have to plot is AT as the y and t as the x. So we have a plot of y versus x, so AT against the t, and then the slope will be negative, which is negative k. For the first order, we will plot ln AT over t, and then we will get a slope of minus k as well. While for the second order, based on this equation, what we will have to plot is 1 over AT over t, and the slope in this case, and only in this case, will be positive. So the line will go up. The linear line will go up. And finally, we also have the half-life for each of the orders. For the 0th order, it is A0 over 2k, like what we just have derived in the previous video. For the first order, it's going to be ln 2 over k. You can derive this on your own as well. And for the second order, it is 1 over k multiplied by A0. This table is the heart of chemical kinetic chapter. Therefore, you really have to understand this, and you also have to remember this very well.